So Google have released a very good project in GitHub. It's open source. It's basically on a large language model foundation, a model that can able to predict the future outcome. It's can able to solve a lot of time series forecasting type of problem with no data at all, right? So which is a very powerful thing, and I've tested it in my local setup. Since it is a large language model, right, so I cannot able to test a very 200 billion parameters of this particular model. So if you can able to look into this particular page, which is its GitHub profile, you can see the particular thing. Last week only they have updated it, and this particular project have been developed by Google DeepMind, and you can see how you can able to install with the help of pip command, right? So I have installed with in as a PyTorch way, which is a lighter model, right? Other basically I found that's very quite a big model that not able to basically pull. So the model is actually currently hosted in Hugging Face. It will basically pull, and then basically you can be able to run locally. So if you can go here, this is my notebook where I have compared three type models. First model is basically a deep learning model called long-term short-term memory, which is a LSTM. Second one is basically TimesFM, which is the model that we are talking about. And the third one is basically on basis of ML and feature engineering. It's a light GPM. So you can see this this is a initial impression where you have a deep learning model trained on your data, whether it is required or not, on the complexity of the particular model. All right, you can see LSTM is basically on deep learning model, right, on the basis of recurrent neural networks. So the training of your data is required. Complexity is medium. You have to code it. You have to train your particular model and then basically predict it. TimesFM, you do not need to train your particular model, right? Straight ahead go your data and then it will basically predict, and complexity is very low as long as you have model locally or you have hosted in your cloud. So this particular TimesFM model, Google also have integrated into BigQuery. So if you're using GCP in BigQuery, you can directly straight ahead utilize this lights TimesFM, and you can able to forecast the future outcome. Light GPM, again ML based, which is a medium complexity. Now evaluation metrics, I'm using mean absolute percentage error, which is a lower is better. Also I'm using all MSE value and MAE value, basically mean absolute error. And you can see the setup. I'm installing some of the libraries and importing it, right? So the libraries basically is written here, right? Like GPM, pandas, numpy, scikit-learn, right? Hugging Face hub for pulling the particular model, right? TimesFM, I'm using torch model, TensorFlow model for basically LSTM models, right? Now let's go back to our notebook, and you can see that I have read the particular data. So the data is at a very simple level, right, where we have trained data and test data, and this is data of last 10 years, right, from 2010 to 2019, sorry, right, including 10 years, right? Those 10 years of data, and then from 2019 to later it will gonna try to predict, right? So this is basically, now after that some helpful metrics. What kind of metrics I want to use? Model, MAPE, MAE value, error, and RMSE, root mean square error, right? The result of that particular model, prediction output, and the training time also that I would try to predict. Now this is the initial how the time series data basically look like. First I use a LSTM model, right? I train on a neural network, where is I use LSTM sequential model, and I use a dense network here, right? And how many units I'm giving, you can directly see here. I'm using Adam optimizer, right? And the loss is basically mean square error loss. I trained it, and then after that basically I do the validation, and then back propagation and the training that happened, and the epoch is 20 epochs, and then basically it took around 173 seconds, and then it's able to predict the output, right, which is fine, right? After 2019, what happened, it able to forecast it. Now this is the value of validation, right? And the second time I did the Google DeepMind. This is the important thing, where I do not want to train my particular data, right? But directly straight ahead I give into the model, and then it will try to predict, right? Original basically trained by Google DeepMind on 100 billion real world time series data, right? It's depending upon the finance, retail, weather, energy, traffic, etc., right? Architecture is basically transformer based, right, which is the latest model type for LLM based. With a patching strategy, input is split into 32 step patches like token in NLP. Zero shot inference, you give it to your history, it forecasts the future, no fine tuning required, right? Model size is basically 200 millions parameter, times FM 1.2 divided by 500 million parameter times FM 2.2. You can just read it here, right? So now you can see that how I'm actually using it, right? I import the times FM library, and then I basically start the counter, and basically I give the hyperparameter. And you can also I'm using CPU, right? Like you can also use a GPU by changing some parameters, right? And then some other hyperparameters, and this is the place where I'm actually pulling the particular model, that is 200 million parameter model, PyTorch model, right? Based upon my current system requirement, which is I have a GPU and then 16 GB of RAM, right? And then immediately in 15 seconds model got loaded, and straight ahead, once the model is actually loaded, then we can able to do the forecasting. You can see this context, and then I'm giving the particular context here, why train, and given the context here, and then after that it is basically predicting, and this is the basically output that after 2019, right? You can see that it able to this particular dotted line is the light is basically times FM output, right? The third one is basically light GBM, again do some feature engineering, and then after that put in the particular model, that's light GBM regressor, and then basically output we got like this. It doesn't look like good, right? But it's ML based, right? You have to do a lot of feature engineering, and then doing the fine tuning, and then get the value, right? But again, the RMSA value, MAP value, MAE value is quite larger as compared to the other, right? Now head-to-head comparison, you can see that this is the forecast which we are expecting, and then the LSTM, which is the blue line, it's actually done a pretty well job. But times FM, since it took a very less time, immediately in no shot it able to predict it, right? Which is incredible. And the last one is basically light GPM, which is again quite deviating from here, right? So if you talk about the overall comparison, right, based upon the timing, based upon what you have right now, right, I will say that if you have the time, if you have the thing, right, then LSTM and a lot of conventional method could be good, right? But for zero shot, definitely times FM is ahead of the game, right? And for more update, more complex model, it will eventually improve, and the light GBM model is basically surviving, right? So best MEP value is basically times FM model, 1.59%. Right. So now based upon this MAP value, you can see that times FM is very less. For ME value, LSTM winning, and RMSE value again LSTM winning, right? So some case the conventional method is still performing well, but still if you do not have any data, right, you want to do the forecasting, then times FM is very much better, right? And if you can integrate with your BigQuery, then you can do a lot of use cases, right? Now inference time of times FM is very less, again 5.5 seconds is nothing more. Light GBM, since it was not performing well, even 2 seconds also does not matter, right? LSTM is 173 seconds, which is quite big. If you have a large amount of data, this number could be significant for you, right? So you can see that what is our analogy, basically the core idea is basically why it is all hype, right? What is a core idea, right? So traditional ML, basically for NLP, right, train sentiment classified tweet. Now right now we have a GPT model where is this a zero shot, is this tweeted positive or not, it immediately tell us, right? So for vision also we have a clip where we have is the cat or not, right, it will give you. Now time series, again just like a GPT model, it's actually giving you based upon history what is the output, right? That's why it is quite becoming very famous right now, right? So again, input data series, patch 32 times steps per patch, transformer encoder, and then predicted patches. This is how the architecture overall look like, right? And it's basically trained on 100 billion plus data points, right, by Google. So that's why it is pretty much accurate, right? So previously might have I confused with 200 billion, right? So right now it's 100 billion only, right? It might be I was talking about the 200 million parameters, right, which was previously we discussed. Now when to use this each model. Now TimesFM best choice when we have everything is a new product, right? Very little data, zero shot, no data needed, quick prototyping exploration, right? Time series deep learning is preferred, right, where you have a lot of complex patterns, right, and you want to capture it, right? Then definitely LSTM is quite good, right? For light GPM, many series, full training data, best accuracy, feature engineering you want to do, right? Then definitely light GPM you can do it, right? For production, low latency, faster inference, small model, then light GPM, of course, right? So this is basically the inside experiment that I did, and then again final summary is basically for best accuracy you can see the TimesFM based upon this MAPE value, right, not other one, right? And the fastest basically in TimesFM, because we are not training anything, right? No feature engineering is also required, right? You don't have to put your time right here. That's why TimesFM is much more better, right? There are also other model like ARIMA model, right, which people are actually using, right? So you can able to use it and then understand that how it is comparing with the TimesFM model, right, and the other model. But again, everywhere you have to train a particular data, right? So that's why TimesFM is here, it is winning in this particular part. Okay, thank you.